All right, let's get this started. Let me share my screen here. I'm filling in for John today because he is on a boat somewhere and cannot be present today. Let me grab my Zoom window here and share. So I didn't have a lot of time to think about this too much, prepare very much, but we do have one exciting development, and that is, so I have removed from the library H5 detect and H5 make lib settings. So now cross-compilation should be a lot easier. There's one to develop today. It'll go to 114, probably not to 112 and to 110 for reasons I'll explain in a little bit. But basically, these two programs here, H5 detect and H5 make lib settings, are run at build time to well, for this one, for H5 detect, this is how we used to do most of our type detection, right? To guess, like, how big everything was, like, longs and doubles and stuff like that, and all their characteristics, so we could populate the type conversion code. So this created a file called h5t-init that set up all that stuff. And there's h5 make lib settings, and this is a program that basically takes the contents of that hdf5.lib settings file that has all the configure flags and stuff like that, and jams that into a string that we stash in the library so that we can emit that. Also, it's kind of convenient if you want to like run strings over the library and kind of see like what the C flags were and stuff like that. So anyway, but these block cross compilation, right? Because if you run H5 detect locally and you're building for some other platform, it's going to give you wrong information. So there's all this. In order to work around this, you'd have to go get H5. You'd have to run H5 detect on a target platform, and then drag that h5t-init file over. And CMake had a way of working around this so that it wouldn't regenerate the file. So it was a big pain in the butt. It prevented a lot of people from cross compiling, and so now it's gone. And so we moved this into the H5T library initialization code. I should make this a little bigger, maybe, so people can see it. And this is now, instead of being run at compile time and jamming that contents of that lib setting, this is less of a problem. People could always just build the lib info off. I think it wouldn't do anything. But now what we do is we have a template file, and that just gets populated with the stuff that your compiler is going to use to build the software. So that's a little easier. So this is, as you can see, there's still, I think I counted, there's like a half dozen issues in the library. People are yelling about cross-compiling, particularly the Julia crowd and the Rust crowd, because they cross-compile stuff all the time to generate their things. So it's giant trains as people talk about all these. What?
A quick question, I missed it. So now when I take .a file and do strings on it, I will not see strings, how library was compiled. That's what you're saying?
You will.
Okay,
Still
okay.
there. Mm-hmm. Okay. Behavior, yeah, the end result is unchanged.
Oh, okay, thanks.
Yep. Mm-hmm. So anyway, I've gone through, I've commented on all these things to ask people like, hey, can I close this? And so people will get back to us and let us know. There are some other things that I put in here in the past couple of days to make some of this stuff easier. There is let's see here. So yeah, so we had these things in here. There were these workarounds that we'd added in a long time ago for these long double conversions. And so I'm actually interested in Elena's opinion on this, but all of these platforms that were mentioned in here are all ancient. Like, we don't care about IRIX and HPUX and any of that stuff anymore. And so so I've pulled all of these out. These were actually done in the auto tools with where is configure AC with where is it, the AC run if else. So these in theory could run at build time, but I did add in, and this will go to 110 and 112 to make cross compilation slightly easier on those platforms. I did add a default in for these, right? So people are building on the auto tools and trying to cross compile. That will try to, it'll guess the thing that is the usual value that we pick. So I added that in. I added some other stuff in here to help MinGW build. I'm very keen on getting that to work. It seems like a lot of open source platforms use MinGW to build their Windows stuff. And so I'm going to try to add GitHub Actions to test it with both building it on Linux and with building it on Windows with MSys. And so hopefully we'll get that set up sometime in the next like month or so. Let's see here. I get rid of this thing here. There you go. Put it up there. So yeah, so we had this PR that went in and got rid of this stuff, and I can show you what was in here. Right. This is the lib setting stuff is not as exciting. I will show you the let's look at the template files that I've created here. So what gets populated is this, right? So this is going to become h5 build lib settings.c, right? It's just a .in file like we do in other places in the library. And then the build system just pastes these values in here. And so this is the thing that is going to create this this global variable. That is, where is the, oh yeah, so this constant char thing that we stick in there, right? So so as you can see, and I did this for both CMake and for the auto tools, and I removed some stuff from that was in the CMake that was not useful. It was putting in a lot of the automake if def or the conditional stuff in here. But yeah, for both CMake and for the auto tools, it will paste in all the information. So you can still run strings over the file and still find how it was built and everything. That is unchanged. So if you look at what's inside H5 detect, so over time, as the library has evolved, as we embraced C99, or more accurately, as Microsoft embraced C99, which allowed us to embrace C99, we have moved much of the functionality of H5 detect out of H5 detect. This used to detect all the types. And if we look back at the 110, this is from the current 110 branch, you'll see these functions that are inside here where we detect a ton of stuff. C89 integers, C89 floats, C99 integers, C99 floats. So we have all this stuff that we were detecting to check, to look at the characteristics of these various types, and then populating the H5T package with that. By the time we got to 114, the only thing that we were detecting anymore was the floats, right? Because the way that floating point types are specified by IEEE 754, but the C standard is kind of less specific about exactly what that stuff is supposed to look like under the hood. It's deliberately kind of vague, as they are with many of their types. So we still do a lot of type introspection to see how things work. We can't just use like a simple like C99 double the way that we can in other parts of the library. And I think that the reason, and Elena can probably weigh in on this, the reason that this stuff was kind of left here was that people are very worried that this was going to cause a lot of startup delay. But if you look at like what this actually did in here, it's not a whole lot. I mean, yeah, it just does a little bit of bit munching and stuff. But for 3 types, I mean, how long does this take? Like, you know, a certain number of milliseconds. Like, I'm not willing to sacrifice cross-compiling on that alter. So we did move this over. But yeah, so that's basically what got moved. Was all that stuff now is in the library, and it just happens at startup time, right? There's this new file in there, this H5T. It's like H5T init floats, right there it is. So I just put everything inside here. I didn't really change the functionality of the code very much. There's I left all that stuff still. Oh, it didn't show the diff because it's big. H5T blue diff. So this is all just exactly the same code that got moved in here. I didn't really change anything. I made it so that it did real HDF5 error handling and stuff. So there's, you know, real go to error stuff in here instead of just before it would assert and abort and stuff and do other unfriendly things that we wouldn't want to do inside the library. But for the most part, it's unchanged. One thing I did leave that was kind of interesting was there was some stuff in here about VAX stuff. So we have like H5T order LE and BE. So when we're trying to determine what the byte ordering is. And so we do have this historical, this H5T order VAX. And I didn't remove this, even though nobody has a VAX anymore that I know about. But ARM does mixed endian. So
It was never implemented. There was intention to implement when VEX was alive, but when we worked on VMS system, we ended up doing just a IEEE standard. I don't know if you can. I think you can remove it because it was never implemented.
Well, okay, yeah. So I thought about that, and because like so VAX does like a weird mixed endian thing, right? Where it's like it's a certain number of like larger words that are like they have their own endianness, right? So there's kind of like two levels of ordering in this. And what we do with this is we try to see, is it big endian? Is it little endian? And then if it's not, we call it VAX, even though really it's just neither of the above. And so, but I didn't want to pull this code path out because ARM can run in a similar type of mixed endian. I've never seen a platform that does this. But just in case this becomes a thing in the future of heterogeneous compute, I've decided to just leave this in for now. I mean, it doesn't hurt anything. It's stable code. It's been this way for 20 years.
Maybe you can rename it and say unknown or mixed or whatever.
I can't. This is a public symbol.
Oh, I see.
Yeah, so it's like, yeah, I could. maybe that's a thing we do for HDF 5.2.0, but I would probably just add another symbol that was like H5T order mixed. But I don't want to start doing aspirational stuff without actual hardware to test on. So if somebody ever comes up with one in the future, we have a place where we can do some of that guessing to figure out how to do that, but without, like, I don't have an ARM board that would that does any of that stuff. I mean, the ARM systems that we have are like basically the stuff that behave normally, and like Raspberry Pi behaves normally. So, and that, even though that's like the HF platform, which can be a little weird, but it all behaves fine. So I'm just kind of leaving it alone. But anyway, that's our big news for now, is that has been removed, and so cross compiling should basically work now. So I'm very happy about that. It seems like a lot of people in the Julia crowd. This is the only pull request I have ever created where I got like where is it? Where people put the little hooray thing on the pull request. That was new. Here, like, we're up to 5, right? So I've never seen that on one. So people are apparently thrilled about this. So any questions?
Well, first of all, it looks great because it was a lot of headache. Have you talked to Sean, Mac person? Because in the past he was building, how they called on Mac, I forgot, unified or universal binaries.
Right there.
Okay.
Yep. He's actually going to start showing. He's going to show up at least at this next one on Thursday.
So it works. It works for him.
I don't know.
Oh.
You're going to try it out.
Oh, because that will be big gain if you can do it.
Yep. I'm trying to slowly go through and get rid of things that were a good idea 20 years ago and are not such a great idea now. The next itch I'm going to scratch is getting H5 pubconf out of the public API. Like, that drives me bananas too. That should not be publicly deployed. Instead, we'll have an H5 features.h header, and that will have all the important stuff, like, is this parallel? Is this VFD turned on? Stuff like that. But all the internal configure stuff, like, do you have alarm? Do you have, stern dupe and stuff like that? All that will be hidden inside an H5 config, and no one will see that anymore.
Then one more suggestion. I believe there were tickets open in, at least at help desk. You can check. People complaining, just contact them so they can tell.
That's a good idea.
Okay.
Help desk and Jira.
I believe some of distributors, Linux, who were working, they were using it.
Okay. Yeah, I'll check on that today. I was just going through today and going through all the issues and seeing what was in there that referenced H5T init or H5 detect.
Right, and they were definitely there.
That's all I got today. I just did mine last week, so.
Just heads up, John is finishing reading my documents. I should be sending them tonight for Thursday.
Okay, cool.
We simplified a lot and it looks much better now. So yeah.
Okay, very cool. I'll pencil that in for the schedule. Is this the sparse document that you're talking about?
Sparse, sparse file format changes and APIs.
You're gonna send that out tonight?
Huh?
You're gonna send that out tonight?
Yeah, I'm sending it as soon as John comes back. Yeah. Especially file format. APIs, he still may have some questions, but file format, I have final questions for him. So, but it looks much better now.
Okay, cool.
All right. Are there any questions, or would any of the HDF group staffers want to jump in to talk about anything? Maybe. Okay, I think we're all clear then. Thank you so much, Dana, for jumping in. I think it is Alexander next week. And we'll talk to everyone then. Thanks, everyone.
Cool. Bye all.
Thank you. Bye.